Hello everyone, let's find out what is the potential energy of a system of charges. Here we mean it is more than two charges. By definition, potential energy of a system of charges is the work done in assembling the system by bringing charges one by one from infinity to their respective positions. To understand this, think for example that we need to bring or we need to keep three charges at the three edges of a triangle. So we need to place charges at a point here and a point here and then a point here. Let's call this as Q1, Q2 and then Q3. So each charge, that is charge Q1 or Q3 or Q2, each of this is being brought from infinity. So in this case, in bringing the charge from infinity, some work has been done. So the work done to bring them and assemble them, that work done is stored as the system's potential energy. So let's find out an expression for this form. Now here let's take three charges. Again, as seen in the previous discussion, let's assume that we bring a charge Q1 from infinity to this point. So bring it from infinity to this point. Again, nothing is opposing this charge Q1. So here, no work has been done. So the work done would be 0. Let's call this as point A. Let's bring a charge Q2 from infinity to this point. So the work done to bring it from here to here, and let the separation between them be called as sum A. We'll make it simple because many books will call it as R12. We'll just keep it very simple as possible. Do understand that here A is the distance between the two charges. As seen in the previous discussions, this work done called as W1. This work done to assemble this is given as K Q1 Q2 by A. So this is the work done. Now let's bring one more charge, say charge Q3 from infinity now. Been brought from here. So this charge Q3 is being brought from infinity to this point. Let the distance from point A to this point C, let's call this as some B and this as some C. So this is called as say B, this is called as C. Now since all the three charges are same polarity, what will happen now here is when bring the charge Q3, both Q1 and Q2 will oppose its motion. So work has been done to bring this against the repulsive force of both the charges. That work we'll call as W2. So here we'll break it up in two different parts. Let's forget Q2 for a minute. So the work done to bring Q3 alone from infinity to this point, that work done would be equal to K Q1 Q3 by B. Now let's forget that Q1 is present and assume only Q2 is present. So work done to bring this charge from infinity to this point would be seen as the two charges potential energy, and that work done would be adding up this also. It becomes K Q2 Q3 by C. So the work done to bring this charge from infinity to assemble here would be this value. Now to find the total energy of the system, in that case it is to assemble everything. That would be total energy would be the work done to assemble them, that will be W1 plus W2, that is equal to A Q1 Q2 by A plus K Q1 Q3 by B plus K Q1 Q2 by C. This is the work done, and this work done is stored as the system's potential energy. Therefore, U is equal to K Q1 Q2 by A plus K Q1 Q3 by B plus K Q1 Q2 by C. So here this is the system's potential energy. Now keep in mind here that whenever we want to find a system's potential energy, in that case we find all the possible ways. We can summarize this in the form of a formula that will be U is equal to summation of say Qi Qj by say Rij, where I is not equal to j. It basically means that we take I from some numbers. Example, in this case I is equal to, I would be 1 2 3, and I can't be equal to itself only, so we can't have q1 q1 or q2 q2, and this Rij basically means it is the distance between two charges. This is what is the formula in this simpler version, but if somebody can't remember, it's fine. Remember that whenever we have a system of charges, find all the possible ways. To understand this, let's take an example of a say a square or a rectangle like this. Let the charges be placed at the four edges. The charge be placed here, placed at the four edges. Let this be called as Q1, Q2, Q3, and say let's make it minus Q4. Now let this point be called as A, B, C, and then D. Now here we get 6 pairs. If you use a combination is what you get. We get 6 pairs here. So U is equal to, find the possible pairs. One pair would be K, Q1, Q2 by AB. And let's start from Q1 only. So we found this pair. Let's find out another pair from Q1. So it will be K, Q1, Q3 by AC, which is the diagonal, plus K, Q1 minus Q4 by AD. So we're done with the Q1, and then let's do with Q2 plus K, Q2, Q3 by BC, because distance between point B and point C is BC basically, plus K, Q2 minus Q4 by BD, plus the last pair is K, Q3 minus Q4 by CD. So this is what is the energy of this system. So in such problems, find the possible pairs.